Hello everyone, good afternoon. Welcome to the class ECE341, the probability and stochastic process course. Today we will just go over the problems of the second midterm exam. We have it this Monday. Right? Let's go over the problems. Okay, ECE341. This is the 11th week, Wednesday's class. So today we go over the problems. So actually the solution. Right? Solutions are midterm exam 2. The first problem. Okay, the problem here. Alright, so the problem is we have a PMF of random variable x, then we want to determine a parameter c, find the mean and variance, and then find the probability. Okay, now we have px, right? We have px. Okay, you can see we have a px. So px, the function the PMF gave us the probability, information of the probability. So here we can find the probability. For x, we can have value 1, 2, 3, 4. Okay, you can say this is the sample space, right? And the probability when x is 1, this will be c times 5 minus 1, right? So this is 4c. This is c times 5 minus 1, it's 4c. And similar, this one will be 5 minus 2, right? 5 minus 2 times c, so this is 3c, and then 2c, and this one will be c, right? 5 minus 4 times c. Okay, then you have these, the following will be very easy. First one, we want to find c. How to determine c? We know the overall probability will be 100%. So 4c plus 3c plus 2c plus c, there will be 100%, the 1. So we have how many c's? 4, 3 to 7, 7, 2 is 9, 9 and 1 is 10, totally 10c equal to 1. So c will be 0.1, right? 1 over 10. You got it. Then b, we have ex. We want to find the ex. Then by definition, this is the summation of all the values of x times its probability. We have this one for x. Now we only need the summation with non-zero values for this part, right? If they're 0, there's nothing. So we will consider these values are not 0. And you see, these values, otherwise they are 0. Only if x is 1, 2, 3, 4, you have this value. Actually, it is just these values. So we can have, this is x is 1 times 4c plus 2 times 3c plus 3 times 2c plus 4 times c. Okay. 1, 2, 3, 4, they are the value of x. And 4c, 3c, 2c, and c, they are the value of px of x. Now you can also get this from here. 1 times 4c, x times probability. 2 times 3c, also x times probability. Right? Then do the similar thing for all the values. 3 times 2c, 4 times c, then do a summation. Okay, this is 4c plus 6c plus 6c plus 4c. This is 10 and 10, 20, right? 20 of c. And c is 0.1. So this is 2. We have mean value. And okay, second one, we want to know the variance. You can use the definition, but you can also use a formula that will be easy. You find e of x squared firstly. So this is similar with e of x, just replace x by x squared, px of x for our x. Right. So this is 1 squared times 4c, and 2 squared times 3c, and 3 squared times 2c, and 4 squared times c. Okay, so this is 1 squared 1 times 4 is still 4c, and 2 squared is 4, 3 4 12, 12c, and this is 9, and 2 9 is 18c, and 4 4 is 16c. So totally is how many? Yeah, we can add 4 and 16, this is 20, and 12, 18, this is 30. So 20 and 30, 50c. So c is 0.1, so this is 5. Okay, we have ex squared. Then variance of x is e of x squared minus square of ex, right? We have this formula. Then we plug in ex squared, e of x squared is 5 minus square of ex, this is 2 squared, so 4, right? 5 minus 4, we get 1. Okay, this is the part B. The answer is this one and this one. And then C, part C, find the probability of the event x larger than 2. Then okay, larger than 2, now there will be 3 or 4, right? 3 or 4, so it is a probability of x at 3 plus probability, you can use the math function, you can also just plug in here, right? It's 4, so this is a 2c plus c is 3c, and the c is 0.1, so just 0.3. Alright, okay, so this is the first problem. Now question 2. Okay, question 2. Alright, this is question 2. We have PDF, right? We have PDF of x, that is fx of x. Here I just copied cx and 0. This is for x between 0 and 4, and otherwise. Okay, if you want, you can give a graph. 0 to 4, here's a c. Oh, cx, sorry. C times x. So it's like this. 0 and 4. cx. This is cx. Right? It's like this. C times x. When this is a 0, and this was 4 times x. So there are 4 times c. X is 4. So it's like this. It's like this. Alright. This is a PDF. Alright. Now what are the questions? First one, we want to determine C. So the basic thing is the area, the integral of this density, there will be the probability. Overall probability is 1. We just use that. So for A, we want the overall probability there will be 1. And this integral, you just use the non-zero values. It is cx, x run from 0 to 4, dx is 1. So we have c times x squared over 2, right? And x run from 0 to 4 equal to 1. So we plug in 4 squared is 16 over 2 minus 0 equal to 1. So this is A, right? So we have C equal to 1/8. Alright, so this is A. This is A. So this one will be 1/2, right? C is 1/8, so this is 1/2. Okay, Then B, we want to find the EX. Okay, this is similar with first problem, but now it is a continuous case, right? This is PDF. It is for continuous type random variable, so you need to use integral of all the values times the density, right, for all the x. But now the fx will be 0 if x outside this interval, so we only need this interval. It's an integral from 0 to 4 x times, what is this? This is cx, so this is cx dx. Don't miss this x. Right? Now we have 2x. One is from the here and the other from fx. Okay, so this is a c times the integral of x squared dx, which is c times x cubed over 3, and x run from 0 to 4. This is, okay, c times 4 cubed. 4 cubed is 4, 16, and 64. 64. So this is 64 over 3 minus 0. Okay, and c is 1/8. So this is 1/8 times 64 over 3. Okay, then we can cancel 1 of 8, so this is 8 over 3. 8 over 3, it is 1.66 infinite, right? It's something like that. Things like that. Yeah, you can keep this will be fine. Keep this will be fine. This will be, yeah. This is approximate. Alright, this is EX. This is EX. This is EX. Then we want to find the variance. Similar, we check the E of x squared firstly. This will be integral of x squared, and the density function, it is cx dx. The integral by formula will be run from negative to positive infinite, but here we only need 0 to 4. Right? Outside there will be 0. Okay, so this is c times, this is x cubed to the integral, and x cubed now is x to the 4th over 4, and x run from 0 to 4. So this is 4 to 4th. So it's a 16 squared, right? So 256 over 4, and c is 1/8. This is what? This is a okay. What it is? Okay, I like this one. Yeah, this is a 4 times 4 times 4 times 4 over 4. Okay, I cancel 1 4, I cancel another 4, and I cancel 2, so it's 8. Am I good? It's 8 anyway. I think it will be fine. Yeah. Then variance of x will be e of x squared minus square of ex. So it is 8 minus 8 over 3 squared. So this is this is 8 minus 64 over 9. It is right here. 72 over 9 minus 64 over 9. That is 8 over 9. It's 8 over 9. 8, right? Minus 12 minus 4, 8. Yeah, 8 over 9. So this is a variance. This is a variance. Alright. This is part 2, part B. Then we want part C. Part C. Second problem, part C. We want to find the probability x larger than 1. For this one, we use this is a continuous case, so we use integral, right? Discrete type we use summation. Now we use integral. Integral for all the x larger than 1. So from 1 to infinite, positive infinite. It is a density function. It's like this. So actually we only need an integral from 1 to 4, right? 1 to 4. And this is a cx dx. So it is c times x squared over 2. X run from 1 to 4, so it is c times x squared is 16 over 2 minus 1 squared over 2, and c is 1/8, 1/8, right? This is 1/8, and this is 15 over 2, so it is 15 over 16. So this is a probability. This is a probability. All right. Oh, it seems larger than 1. Right? It looks like this, from 1 to 4, and 1. This is 2. This is a 0 to 4. So 1, 2, 3, 4. So this area of this, yeah, it's good. Right? It's very close to the whole space. Yeah. So this is a part C. Part C. Okay. All right, and go to next. All right, here we have temperature of November in Chicago. Oh, well, I just this is imagery. I put it is normal distribution with mu is 40 and sigma is 5. Or maybe different. Just this is a problem. Just the imaginary. Okay. Problem 3. We have a temperature T, a normal distribution with mu is 40 and sigma is 5. Then we want to calculate some probabilities. Okay, just step by step. The first one, we want the probability T smaller than 32. So for this kind of problem, this is normal distribution. So we always do this. We try to use a Z, which is a standard normal. This is not standard. We want the standard one. We consider the probability T minus this 40, minus the mean. This is the mean. This is the mean. This is the mean. So minus this mean and divided by the standard deviation 5. This one was smaller than. Okay, you do the same thing, right? You minus 40 and divide by 5 on this T. Then you want to keep this formula, you will do same thing on 32. So this is 32 minus 40 over 5 to get this one. You get this one. Then this, you say this is Z. So this is P of Z smaller than, this is how many? Negative 8 over 5. So it's negative 16 over 10. Right? So negative 1.6 is this one, where Z obey the standard normal distribution. The standard normal distribution, that means it has expectation value 0. The mean value is 0, and the variance is 1 square, or standard deviation is 1 square. Yeah, this is the same. Here's the difference. Standard deviation is 5, variance is 25 square. Now here's both standard deviation and the variance are 1. Okay, then what is this? Now we want to check the table, but we know the table only consider the case this side is a positive value. Now it's a negative value. What can you do? You can say this is standard deviation, the mean value is 0. This is density function, and you want this part. This is negative 1.6. Negative 1.6, right? You want the area, the probability, the area of this part. Then in the table you can only find the positive side, so you use the symmetrical part. This part, they are same. This area are same. So you check this 1.6. You can find this part with the help of table. Not exactly from table, but you can find it from the table, right? Okay, we check the table. Table is here. Okay, table is here. We have 1.6. 1.6 is here. Is 0.9452. So that means from here, this area, the outer area here, under this curve, that is a 0.94, 1.6, 9452. Okay, this one. So you can know this one will be 1 minus 0.9452. Right? Okay, you can write it, just put a number here, or you can write as a formula. This is a 1 minus phi of 1.6. This table is denoted by phi. So it's a phi for the normal distribution, but it's a standard one. Standard normal distribution. It is this one, right? Standard normal distribution. So you have, this is the phi. This is CDR. This is the phi, right? The area under the density function is phi. Okay, now it's 1 minus 0.9452. It is a 0.0548. Okay, so this is one. Problem 1. Then the part 2. Part 2 is the probability of t larger than 50. That's similar. Firstly we try to change t to be a z, which is a standard normal distribution, so t minus the mean divided by the standard deviation phi, and we want to keep this inequality. There will be 50 minus 40 divided by phi. We do the same calculation, right? So this is a probability of z larger than, this is a 10, right? 10 over 5 is equal to 2. Okay, z larger than 2. Now is a z larger than 2, right? So we want this area. Then we also write it as 1 minus, this is a phi of 2, right? Smaller than 2, it is a phi of 2. Alright, 1 minus, what is phi of 2? Okay, I keep it, and we go to the table later, right? I have two more parts. Let me check the table same time. Okay, this is part 2, and part 3, probability of 35 smaller than t smaller than 45. So this is now we do the similar thing, but we have three numbers, right? 2 numbers and 1 variable. We do the same thing. 35 minus 40 over 5, smaller than t minus 40 over 5, and then smaller than 45 minus 40 over 5. So this is probability of 35. This is negative 5, so negative 1, smaller than z, smaller than 1. Okay, this is density function. We want from negative 1 to 1. We want this part. And we know phi 1. This is phi 1. This is phi 1. Right? This is phi 1. And this part is 1 minus phi 1. Right? 1 minus phi 1. And this part, they are same. Right? They are same area. This area are same. Okay, so this part is this part, right? This part is this part. So the whole thing is we want these minus these, right? This one, this is 1, this is a 2. So it is 1 minus 2, right? This will be 1 minus 2. So it is phi 1 minus 1 minus phi 1. This is part 1. This is part 2, right? Part 1, part 2. So it's this one minus this one. Alright, then what is a phi 1? Now of course you can do simplify. Here are 2 of phi 1 minus 1. Then we can check the table. I leave this later. Alright. And part 4 probability of absolute value t minus mu smaller than 2 sigma. What it is? Okay, here we have absolute value, right? So you remove the absolute value firstly. You will have t minus mu smaller than 2 sigma, but larger than negative 2 sigma. Yeah, when you remove absolute value, you can always work like this. Okay. Yeah. Okay. Then, right? So I can just divide by sigma. I can get z. So it is p of negative 2 sigma over sigma smaller than t minus mu over sigma smaller than 2 sigma over sigma. Right? Then I have probability of negative 2 smaller than z smaller than 2. Yeah, here I even do not need plug in the value of mu and sigma, right? We know mu is 40, sigma is 5, but here they cancel, right? So we even do not need to plug in those values. I have this one. Okay, then similar with this. Here's a z from negative 1 to 1. Now we have z from negative 2 to 2. So the result will be 2 of phi 2 minus 1. Now similar with this, you just change negative 1 and 1 to be 2. You get similar graph, similar idea. Then you can have this one. Alright, what it is? Alright, now let's check the table. I have 3 problems. I need a table, right? Go to table together. Alright, this one, okay, the last one is 2. 2 is here. 2 is here. This is z is 2 and phi is okay, it's 2 times 0.97725. Alright. 27. Yeah, double 7. Okay. So and minus 1. What it is. And in times. So 250, 2 is 4, and I have 1 going up, so this is 5, and 27 is 4, 27 is 14, right? 27 is 14, and 27 is another 14, now it's 15, and 29 is 18, but I have 1 up, so it's 9, and before here I should have a 1, but subtract by 1, so here just 0. Okay, so this is part 4 is 95445. It is like 45%. Yeah, I keep this word fine. And this one now is 2 times phi 1. What is phi 1? Yeah, this one 2 times phi 1. Phi 1 is, check the table. What is this here? 0.8413. So it's 0.8413 minus 1. So this is 2 times it. 2 3 is 6. 2 1 2 is 2. 2 of 4 is 8. And 2 8 is 16. 16. Here should be 1, but subtract by 1, so 0. Okay, so this is part 3. The answer is here. And then we have part 2. It is 1 minus phi 2. Oh, I already get phi 2 here, right? So I can use it again. It's 1 minus this one. It's part 2. I want 1 minus phi 2. I already have phi 2 here, right? This is phi 2. This is phi 2. So it's a 0.97725. Alright. So this is 1 minus it. So it's a 0.02275. Okay. So this is problem 3. Problem 3. Okay. Yeah, this is a problem about how to find the probability when we have a normal distribution, Gaussian distribution. This kind of distribution we use it a lot. You know, different area we always use it. Okay, then problem 4. Problem 4. Problem 4. Okay, now we have a pair of random variables, right? We have two random variables, x and y, and we have joined PDF of x and y It is fxy of lowercase x and y equal to cx or 0, and here is for x run from 0 to 4 and y run from 0 to 2 as well. Anyway, okay. Then we have A, B, C, D, E. We have 5 parts. The first part we want to determine C. Now, similar with one random variable case, you just want the overall probability is 1. So you integral for the whole things. Now we have two integral, right? Two-dimensional integral. I have fxy of xy dx dy equal to 1. So we try to solve this to get C. Okay, plug in. We put the whatever in the front. So like I use x 0 to 4. This is 4x. This is just 4x. Cx 4. Sorry. Cx integral by dx. Okay, this is the part. And then for y 0 to 2 is dy equal to 1. Now you can also use a different order. You do the integral of y firstly. That result will be same. Okay, then I do this part firstly. This is a c times x squared over 2 and x run from 0 to 4 dy equal to 1. So this is a c over 4 times x squared. X squared is 4 squared minus 0 squared, right? Okay, dy equal to 1. And well, we can cancel one of the 4, so it's a 4c integral. 4c is constant, and the integral of 1, right? 4c integral of 1 dy, and y run from 0 to 2. This is 4c times y run from 0 to 2, right? The one integral you get that variable, right? Okay, so this is 2 times 4c is 8c. 8c equal to 1, so c is 1/8. Am I good? Okay. Well, I think I did this before. Problem 2. I lost something. Sorry, I got something wrong. Oh, here. The x integral will be x squared over 2. So here should be 2. 2 that I cannot cancel it. So I can. This is 4 squared over 2. So this will be 16, right? 16 over 2, that will be a. So this will be a. Then this will be times 2. So this is 1 over 16. Okay, now it's good. Alright, this is part A. This is part A. So we have C. And then we go to part B. We want to find the marginal PDF. So fx of x, well, this you just follow the definition. You have fxy, right? You do the integral for y, Then you have the marginal distribution of x, right? Y is used. You do the integral for all of the y. And now this is a fxy. It is 4x, cx. It is cx, and the dy. And y will run from 0 to 2. Right? Y run from 0 to 2. But you check the problem. Y run from 0 to 2. Okay, when you integral on y, you just treat x as a constant. So this is cx times integral of 1. Then it is cx times, this is 1, so you get y. And y run from 0 to 2. Yeah, I write in this way in case you confuse x and y, right? This 0 and 2 is the value of y, not for x. Then this is cx times 2 minus 0. Okay, now plug in c is 1 over 16 times x times 2, so it's x over a. X over a. Am I good? X over a. And run from, yeah, this is good. Okay, this is fx. This is fx. But of course, you have a restricted x run from 0 to 4. 0 to 4. So when you do this calculation, you only work for x run from 0 to 4. All the other values, they are zeros. You do integrals, still zeros, right? So here we want it's for x run from 0 to 4, and you can, so you put this one, it is x over a or 0. Here is for 0 smaller than x smaller than 4 and other wise. Okay, so this is for fx, and similar for fy. There will be integral of the density function. Now is for x, dx, integral for x. So integral x will run from 0 to 4, right? X run from 0 to 4, and the density is cx and dx. And here, of course, this is for the let me see, for y will run from 0 to 2. Okay. X run from 0 to 4 and y run from 0 to 2. And this one, you do integral, you have c times x squared over 2, and x run from 0 to 4. So this is c times x squared over minus 0, right? So over 2. And the c is 1/16, and this is 16 over 2, so it is 1/2. Okay, now you have fy of y will equal to 1/2 or 0. Here for y run from 0 to 2, and otherwise. Alright, so this is fy. Okay, then next D, C. Are they independent? I say yes. You see, you times these two, you get the joint density. So C, because fxx times fy of y equal to x over 8 times 1 over 2, that is x over 16, equal to the this is the case for 0 smaller than x smaller than 4, and 0 smaller than y smaller than 2, and 0 otherwise, right? Equal to fx y, x and y. So we have this one. We have this one. We have this one. So x, y, they are independent. They are independent. This is independent. Then A, B, 1C, RC. Oh, this is C, already C, and this is D, part D. What are the values EX, EY, variance X, variance of Y? Alright, here you can do the calculation just based on the definition because you already have the density function for both X and Y. So you base on this Fx, you can find the mean and the variance of it. You also base on this Y. This one you can find the mean and variance of Y. But here you can do some simplify. Actually, we did it before. The part B, this one, it's just the same as in problem 2. Yeah, if you mention these, you can just use the answer from problem 2. If you didn't remember that, you need to do some calculation, but then you will find, okay, you do the same calculation actually. So by 2, problem 2, now you can also do the calculation right here. I just write in a shorter way. We have EX is, what is it? We have it here. It is 8 over 3, and the variance is 8 over 9. Yeah, this is EX. This is a variance of X. It's coming from problem 2. Problem 2 here is X run from 0 to 4, and the density is X over 8. X over 8, right? And it is same, right? This is X over 8 when X run from 0 to 4. Okay, this is problem 4. The part B, you get this one, right? So this is the same as problem 2. So we can have this, and this is EX, and Y, it is a uniform on interval 0 to 2. This is Y. This is density function of Y. It is a constant value on this interval. So this is a uniform distribution on 0 to 2. And this value is 1 over the length of the interval. Right? So this is uniform. Uniform over the interval 0 to 2. So we can have EX is 1. There will be middle of this. It is 1. It is 0 plus 2 over 2. Or you say A plus B over 2. You can check the formula. This is A, this is B. You check the textbook, they have the formula on the uniform distribution. And the variance of X, there will be B minus A squared over 12. Now it's 2 squared over 12. It is 4 over 12. It is 1 over 3. This is variance of Y. Variance of Y. Alright. Here's part D. Then part E. Part E, we want to find Rxy. By definition, this is the E of X times Y. And I have a hint here. If X and Y are independent, this one you can just calculate by EX times EY. Right? And we have EX and EY. EX is 8 over 3, and EY is, where's EY? Oh, I miss EY? Oh, no. This is EY. Sorry. Not F. This is Y. This is Y. Yeah, EY is 1. Okay, so this is just 8 over 3. This is RXY. RXY. And then the covariance x and y. This one we have formula. Remember, this formula is e of x times y minus ex times ey, and the exy is over 3. We just get it, right? Exy, this one, and minus ex is 8 over 3, and ey is 1, so it is 0. And then rho xy. Rho xy, by definition, it is covariance of x and y divided by standard deviation of x times standard deviation of y. Okay, now it doesn't matter what are these standard deviations, because covariance is 0, so it is just 0 over something, still be 0. Okay, we are done. We have all the problems. Alright, okay, that's all for today. Yeah, 46 minutes, almost 50 minutes. Alright, okay, then see you next time. Bye bye.